Welcome to this beginner's guide on static classes and singletons, two fundamental concepts in programming. We'll delve into their core definitions and practical applications, providing a solid foundation for your software development journey. We'll explore what these concepts are and why they are incredibly useful in software development, helping you write more efficient, organized, and maintainable code. This tutorial is specifically designed for beginners, breaking down complex ideas into easy-to-understand steps and relatable examples, ensuring that even those new to programming can follow along effectively. You can expect a clear, step-by-step explanation of each concept, ensuring you grasp the core principles and can confidently apply them in your own projects. We'll build knowledge incrementally. We will demonstrate these concepts practically within Visual Studio, a powerful integrated development environment, and the Unity 3D engine, a leading platform for game development, showcasing their real-world utility. Throughout the video, we'll provide helpful tips to enhance your understanding and application of static classes and singletons, offering insights that can save you time and improve your coding practices. First, let's define what a static class is in C# programming. Understanding this foundational concept is crucial for grasping how these classes function and where they are best utilized. A static class is a special type of class that cannot be instantiated, meaning you cannot create objects from it. This is a key distinction that sets it apart from regular classes, as its members are accessed directly through the class itself. It exclusively contains static members, including fields, methods, and properties, which belong to the class itself, not to any specific instance. This means these members are shared across all parts of your application that reference the class. Static classes are typically used to group utility or helper methods that do not rely on object-specific state. Think of them as toolboxes filled with functions that perform general tasks, independent of any particular object's data. These methods can be accessed directly through the class name, eliminating the need to create an instance. This direct access simplifies their use and makes them ideal for common, repeatable operations. Let's see an example in Visual Studio. We'll create a new C# console application to demonstrate the practical implementation of a static class and its members. Here, we declare a static class named MathHelper using the static keyword. This keyword is essential as it signals to the compiler that this class cannot be instantiated and will only contain static members. Inside MathHelper, we add a static method add that takes two integers and returns their sum. This method doesn't need any object-specific data to perform its calculation, making it a perfect candidate for a static method. From our main method, we can call MathHelper, add directly, without creating an object. This demonstrates the straightforward way to utilize static methods, providing immediate access to their functionality. Key characteristics of static classes include their inability to be instantiated and their exclusive use of static members. These properties define their fundamental nature and how they interact within a program. They are also sealed by default, meaning they cannot be inherited by other classes. This design choice prevents unintended modifications to their behavior through inheritance, ensuring their utility remains consistent. A helpful tip: use static classes for utility functions that don't require any object-specific state, like mathematical operations or string manipulations. This keeps your code clean and ensures these functions are readily available without overhead. Now, let's move on to understanding singletons. This design pattern offers a different approach to managing unique instances within your application, with distinct advantages and use cases. A singleton is a design pattern that ensures a class has only one instance throughout the application's lifecycle. This guarantee of a single instance is central to its purpose and application. It also provides a global point of access to that unique instance. This means that from anywhere in your code, you can retrieve and interact with the very same instance of the class, facilitating centralized control. Singletons are useful when you need to control access to a shared resource or maintain a global state, such as a configuration manager, a logging service, or a database connection pool. They centralize management of critical components. The implementation typically involves a private constructor to prevent external instantiation. This crucial step ensures that no other part of your code can directly create new instances of the singleton class, enforcing the one-instance rule. A static field holds the single instance of the class, initialized lazily or eagerly. Lazy initialization means the instance is created only when it's first needed, while eager initialization creates it at program startup. A public static property or method provides controlled access to this instance. This is the designated gateway for other parts of your application to obtain and interact with a unique singleton object. Here's a basic singleton implementation in Visual Studio with a private constructor and a public static instance property. This structure is a common and effective way to implement the singleton pattern in C#. We access the singleton instance from the main method using mySingleton. Instance.doSomething to call its methods. This demonstrates how easily you can interact with the singleton's functionality from anywhere in your application. In multi-threaded environments, thread safety is crucial for singletons. A basic thread-safe implementation uses lazy T, which ensures that the instance is created only once, even if multiple threads try to access it simultaneously. Helpful tip: use singletons when you need a single, globally accessible instance of a class, like a game manager or a configuration manager. They are ideal for centralizing control and state for critical application components. Now, let's compare static classes and singletons to understand their key differences. While both offer ways to access functionality without direct instantiation, their underlying mechanisms and appropriate use cases vary significantly. Static classes cannot be instantiated, meaning you can never create an object from them. In contrast, singletons have a private constructor and a single static instance that is carefully managed to ensure uniqueness. Static classes can only contain static members, which are tied to the class itself, whereas singletons can have both static members and instance members, allowing them to hold and manage specific state data. Static classes cannot be inherited, making them final and unextendable. However, singletons can be inherited, offering more flexibility for extending their behavior or creating variations of the singleton pattern. Furthermore, static classes cannot implement interfaces, limiting their ability to conform to contracts. In contrast, singletons are capable of implementing interfaces, which enhances their testability and allows for polymorphism. Static classes typically do not maintain state, functioning primarily as stateless utility providers. But singletons are specifically designed to maintain and manage state, acting as central repositories for application-wide data. Regarding memory, static classes use stacked memory for their static members, which is allocated once, while singletons utilize heap memory for their single instance, allowing for more dynamic and object-oriented memory management. Singletons are generally easier to test because they can implement interfaces and be mocked, allowing for isolated unit testing. Unlike static classes, which are harder to mock due to their static nature, singletons offer greater testability. Use static classes for utility functions that don't require state, like a collection of mathematical functions or helper methods for string manipulation. They are perfect for operations that are universally applicable and don't depend on specific object data. Opt for singletons when managing global state or shared resources, such as a central game configuration, a user session manager, or a logging system. They provide a controlled and unified access point for critical application components. Let's see how these concepts apply in the Unity 3D engine. Unity provides a powerful environment where both static classes and singletons can be incredibly useful for game development, each serving distinct purposes. First, we'll create a new Unity project to set up our environment. This will provide a clean slate to demonstrate the practical implementation of static classes and singletons within a game development context. We'll create a C# script called GameUtilities and declare it as a static class. This class will house various helper functions that can be accessed from anywhere in our game without needing to create an object. Inside GameUtilities, we add static methods for common game tasks, such as generating a random number within a range or performing specific calculations. These methods are universally useful and don't rely on any particular game object state. We can then demonstrate calling these methods from other scripts, like a player movement script, for easy access. This shows how static utility methods streamline common operations across different game components. Next, we'll create a C# script called Game Manager and implement the singleton pattern. This game manager will serve as a central hub for controlling various aspects of our game, ensuring a single point of control. This game manager will have instance members to manage game state, such as the player's score, the current level, or global game settings. These instance members allow the singleton to maintain and update critical game data. We'll demonstrate accessing the game manager instance from other scripts to update and retrieve game state. This highlights how different parts of the game can interact with the centralized manager to get or set information. To persist the singleton across scene loads, we use Don't Destroy on Load in the awake method. This crucial Unity function ensures that our game manager instance remains active and accessible even when transitioning between different game scenes. Helpful tip: you can configure singleton properties directly in the Unity inspector for easy adjustments. By exposing public variables, you can fine-tune your singleton's behavior without modifying code, making development more efficient. Let's discuss best practices and common pitfalls when using static classes and singletons. Understanding these guidelines will help you leverage their power effectively while avoiding potential issues in your projects. Beware of overusing static classes and singletons, as they can lead to tightly coupled code and make testing difficult. Excessive reliance on them can reduce flexibility and introduce hidden dependencies within your application. Consider alternatives to singletons, such as dependency injection, for more flexible and testable designs. Dependency injection promotes loose coupling and makes it easier to swap out components, improving maintainability and testability. Always reiterate the importance of thread safety in singleton implementations, especially in concurrent environments. Without proper synchronization, multiple threads accessing the singleton simultaneously can lead to unexpected behavior and bugs. In conclusion, we've covered the essentials of static classes and singletons. We've explored their definitions, purposes, and how they are implemented in real-world programming scenarios. We defined their purposes, explored their implementations in Visual Studio and Unity, and highlighted their key differences. This comprehensive overview should provide a solid understanding of both concepts. To further your learning, explore advanced singleton patterns or delve into dependency injection frameworks. These next steps will deepen your understanding of architectural design and help you build more robust applications. If you found this video helpful, please like it, subscribe to our channel for more content, and leave your questions or suggestions in the comments below. Your feedback helps us create more valuable tutorials. Thank you for watching, and happy coding! We hope this guide empowers you to confidently use static classes and singletons in your programming endeavors.